you already heard a lot about of argumentation, and now it's a pleasure to me to present to you Mr. Jan Reich. Jan is Master of Science, applied for computer science. He is at the Fraunhofer IESE Institute, which concerns with safety, especially, and is expert scientist for dynamic assurance for connected automated systems, so health systems and so on. And Jan was the coordinator of, we call it Core 3, that was an integrating team for the argumentation. So he is one of our special experts for the argumentation. It's a pleasure to me to give him the stage. It's yours.
Yeah, thank you, Roland, for the kind introduction. I have the honor today to take you on a little journey to one of the key elements of the VVM project, the Assurance Argumentation Framework. After this talk, hopefully I was able to transfer why an explicit safety case is important for ADS safety assurance and how we can build it up based on the research that we have performed in the past 4 years. So I would like to start with a representative photograph of the desks of some of our anonymous colleagues who might be safety responsibles in their companies. Seems pretty crowded over there, right? What we see is a plethora of artifacts that are all relevant for safety assurance, each one important in its own right. However, the sheer number, the degree of details, and also the partly complex interrelationships and dependencies between these artifacts make it very difficult to answer it. The question that we all seek to answer: why is this ADS safe? In fact, what we are after is the story of the safety of our system, i.e. an explicit view on how we can combine argument and evidence into a bigger picture that enable us, or that enable the stakeholders, to get access to the story of our system. So let's dig into the VVM safety story. It starts with a definition of what safety means for us. The absence of unreasonable risk as a top goal was further decomposed into sub-goals. We have seen that slide. But it is important that each of these sub-goals addresses a different aspect of risk. Functional safety, SODIF, laws and regulation, as well as ethics and safety performance have been clearly in scope of our project, while human factors, cybersecurity, and other aspects like implementation updates or V2X are all equally important, but we put it out of scope of our project. So for many of these aspects, industry standards exist that capture best practice on how to achieve the respective assurance. And as I speak, many more are in progress, especially in the automated driving area, that will come into effect soon. Our final goal must be to provide an argumentation story which efficiently addresses the aspects and substantiates the satisfaction of the safety goal. Before I dig into the VVM argumentation structure in detail, I'd like to differentiate 3 fundamental concepts which are often confused. So a lot of people, when they hear safety cases, they immediately associate this with the goal structuring notation, short GSN. But that is not the full picture. The first concept is the concept of generic argumentation principles. They are independent of the system class or the domain in which the system should operate. And this means that for assuring the safety of any kind of system, 4 aspects need to be reasoned about. Number 1, the system performance. So we need to demonstrate that the system achieves what it is supposed to achieve. This could be, for instance, shown by a set of past validation tests. Second, the process. So how did we build our system and why was this effective? This can be demonstrated by the use of systematic methods. That was one of the focuses of our project. And confidence and dialectics are less properties that we address with respect to the system or process, but there we ask ourselves whether our argument itself can be considered valid. So in a way, we are taking a meta perspective on argumentation and ask why we can trust our argument and potentially whether there's reason to believe that we cannot trust it because there might be a lack of knowledge. So the second concept is the concept of concrete argumentation structures. So these structures emerge if we apply these generic principles to concrete context. I brought 4 example concrete argumentation structures which emerged in research, in industry, or from standardization. However, there exist many more. The important message is that these concrete argumentation structures are an application of the principles for a concrete context of a system with specific challenges. For instance, for the automated driving system class and complex environments like we are dealing with at the moment. So this application or this concretization happens based on assumptions about how we can build and assure safe automated driving systems. And defining those assumptions and telling a convincing safety stories on top of them is actually the hard part. The third concept is the safety case documentation. So this is no less important than the other 2 aspects, but it is like based on an argumentation structure that we instantiate for a concrete system. We use the safety case with established notations like the goal structuring notation or claims argument evidence to make it communicatable to stakeholders who need to understand the safety case on a more higher level so that they know how to navigate through it. Put simple, argumentation principles are realized in argumentation structures which are communicated via documented safety cases. Our goal in VVM was no less than the hard part. And our task was to define this minimum set of industry-grounded assumptions about the processes for ADS assurance and providing a structure for the plot of the safety story. In Roland's talk, we heard about the 3 VVM key components: risk management, a global development and operation model, as well as a scenario-based assurance approach. Tightly integrated with this framework, we formulated an explicit safety case pattern, which is decomposed along the aggregation points within this assurance framework. Just like the pillars of a bridge, where each pillar takes a small load, but still the stability of the whole is preserved. So, here an example of this divide and conquer approach to decompose the argumentation problem. This is a familiar picture because Roland used it. It's some of these aggregation points that I just mentioned on the last slide. So how do we build up the argumentation on that? So in the first step, we are thinking about an operational concept, which contains stakeholders and their concerns, and therefore represent, let's say, the context for a particular automated driving system project. So we need to argue why this operational concept is fit for the purpose, so that we did not miss important stakeholders and their concerns. So based on an argumentation that is just substantiating this claim, we go on to the next aggregation point and ask ourselves, did we choose the right top goals and appropriate acceptance criteria for checking whether the concerns have been met? In the next step, we are arguing specifically why what we consider a safe target behavior specification is living up to the expectations of the top goals. Further on, we are specifying capabilities which need to realize this safe target behavior, and it's not an implication that this is the case. And last but not least, we are having the V&V concept for which we need to definitely argue that this V and V concept, if we perform the verification and validation according to it, actually implies that the system possesses the safe target behavior and is acceptable with respect to the defined criteria. Having understood the general argument decomposition logic based on these aggregation points, now let's substantiate a little bit more the top-level logic of the VVM ADS safety argument. So a deployment decision depends, hopefully, on the knowledge about how much risk actually the system exposes to the operational world, so to say. So since we cannot measure the real risk because it happens after deployment, we need to predict it. We do this by putting the ADS into what we call a verification validation system. And through this examination, we can arrive at a prediction of risk. However, what we definitely must not do is underestimate this risk. And in order to do so, we try to handle all the sources that may lead to an inadequate risk estimation and in consequence lead to an underestimation. So an obvious source is what we are already seeing here, the ADS and the verification and validation system itself. If they still have residual failures, functional and performance insufficiencies, this may lead to an inadequate risk. The second source, however, are the processes that we use for problem space analysis, ADS development, and verification and validation. So do you remember the performance and performance generic principles from the last slide? That's the first concretization for the context of ADS and the environment, and the respective processes, obviously. And the last source for inadequate risk estimation is the overconfidence in our argument for this system and process performance. So if we can tell an explicit story of how we identify and handle all these sources, we can arrive at a trustworthy risk estimate for a system and use that later on to check it against risk acceptance criteria. So I think it's time for an intermediate summary. So we started off with the safety assurance artifacts, with a rather hidden storyline on how, a hidden story plot that is hardly understandable by some of the key stakeholders and therefore may lead to raised eyebrows. And we are transforming this into a substantiation based on our assurance framework. So the aggregation points on our ADS artifact desk, combined with an explicit safety argumentation, together achieve a hopefully transparent and explainable story for compliance with normative requirements. So now let's dig into some of the key structuring schemes that we have as part of our argument. So this is it, our argumentation structure. We have two different levels of detail, and the first one is shown on the left and captures the core strategies that we use to arrive at an understandable argumentation. So this is important because if we would directly start with the right-hand side, so the detailed one, then it's very hard to localize the key strategies that are used to structure the argument, so it is very hard to communicate in consequence. So the second, the more detailed exemplification of the argument on the right side is, in fact, the concrete argument that we produce as part of our work. And we did not focus on all aspects in detail. So that would have actually not be possible time-wise. Instead, what we tried to do is we picked out some of the key and toughest challenges that we saw and detailed these out. And later on, we will have also detailed talks that kind of dig into these different directions in the argument, in the concrete one. So, the top-level strategy is the strategy that is dealing with how to operationalize the absence of unreasonable risk. It contains two aspects, and I partly prepared that already with my last slides. On the left-hand side in the argument, we are dealing with arriving at a trustworthy risk estimate. And this is not everything. We definitely need to actually select risk acceptance criteria and also lay out in our argument why the risk estimate is acceptable given a methodological approach to compare it against these acceptance criteria. So our efforts in VVM have been rather put on the left-hand side because risk acceptance is a topic that needs to be solved on a societal level and is the subject of ongoing debate as well. So this means like we did not detail this branch very much out. But on the left side, we put all our efforts in and try to come up with an argument that is based on a systematic approach for balancing the risks of a hazardous event with the risk reduction measures, and thereby putting these together to come to a higher level risk estimate. That is something that will definitely come later in the presentations regarding the risk management core. So, but which aspects are now relevant for this risk estimation? So, let's go one step deeper to the next layer and talk about the decomposition of sources of inadequate risk estimation. That is basically the slide that we've seen like a couple of minutes ago and is the reason where we put these generic argumentation principles as first-class citizens also in the overall idea on how the VVM argument should be structured. So I said earlier, independent of the system kind, these aspects are relevant. So, and that is how we and where we put this in the VVM safety argument. So the performance and process aspects directly map to the two branches that we are seeing in the middle and left. And on the right-hand side, we somewhat combined the confidence and dialectic argumentation into what we call the concern management branch, which somewhat captures this meta perspective of always asking, are we still right? Is the evidence sufficient, or are we wrong and something is missing? So basically the right-hand side branch also tries to constantly break the argument. So this is somewhat of a dual perspective that you can take. The next decomposition going into the performance assurance branch, we have two sub-branches where we're dealing with the performance of two different types of systems. The ADS, what we are most interested in obviously, and the V&V system, so the verification and validation system. For the ADS side, what the argumentation is built up upon is the definition of capabilities for a safe target behavior, its technical implementation into a system, and an evidence that substantiate the real-world performance through validation. These three aspects are part of the scenario-based approach of VVM and will be dealt with in much more detail in the immediate next talk by Helmut Schittenhelm. Providing the evidence for the ADS is like a key aspect and very tough, but it's not all, unfortunately. What about the credibility of the tool chains we are using for performing verification and validation? If I have exactly the right scenarios and test cases, but my tool chain is not credible, how much can I trust in the results? So this is definitely not trivial. And since the V&V tool chains got much more complex to realize a scenario-based approach, the V&V system needs, so the V&V tool chain needs to be treated as a system in its own right. And this means that we account for this in the VVM argumentation structure by dedicating a concrete branch on a similar level like the ADS because it's so important. And this also means that we can perform this argument for the V&V system credibility based on capability engineering and real-world layers as well. However, the concrete methods and the argumentation for really technically performing this argumentation was not in scope of VVM, but we had a sister project that ended last year and was called Z-Level. There, the scope was really building up a credible simulation process that can be used to substantiate this argument branch. So this means in VVM, we provided a placeholder for the integration of the Z-Level project. The next big branch is the process argumentation branch, and its task is to provide the justification for an adequate selection of process capabilities that we needed, or that are needed in organizations, for their implementation by means of concrete processes, methods, and tools. And similar like for the system side, we also need to look to provide evidence for the real-world performance of processes. So I believe everyone who worked in practical projects knows that process definition and process execution sometimes might have a little deviation, so that's why we need to really look into it and provide the evidence why this deviation is acceptable. So we detailed out this branch with 3 process classes: problem space analysis, ADS development, verification and validation. And what we're seeing on the right in the VVM global development operation model is actually a zoom in on how these 3 branches can be more detailed out. So what is important to highlight is that VVM does not dictate any processes. Instead, what we're making is a proposal to inspire the organizational landscape, because every company is different, with our methods for verification, validation, and overall the assurance. Last but not least, we have the 3rd branch and last branch, which is dealing with the argument validity, which is equal to managing uncertainties associated with concerns. Where can these concerns emerge? Answer is anywhere in the argument. So at any place in the argument, either an objective entity, like a metric, or a subjective entity, like an expert, can have concerns about whether this argument is valid, whether the implications from sub-goals to top goals are appropriate. And this is something that needs to be handled systematically. How do we do this? Well, we identify concerns we systematically identify the concerns in the overall argument. We evaluate the impact of these concerns. We handle them if the impact is something that we don't want, and reevaluate. And this is something that is repeated continuously, not only during the development, but also continues to happen and should happen after our systems are deployed in the field. Why is this systematic management important? Well, because the complexity of system and environment are much higher than they used to be for, let's say, the previous generation systems. And this increases uncertainty. And this is, hopefully you agree with me, true for automated driving systems. But what makes things worse is that the context changes. So it is not only a nice to have, but a necessity to continuously preserve the argument validity over the whole life cycle of a system. Coming to the end, I started with 2 promised outcomes. The first is an answer to the question, why is an explicit safety argument important for ADS assurance? And my answer would be that the explicit safety story is required to explain compliance with normative requirements to stakeholders. The second outcome, I promised how we can build up such an argument systematically. The answer is, we can build up such an argument based on the VVM assurance framework which is built upon an industry-grounded proposal for risk management, global development and operation, and scenario-based safety assurance. So I hope that my two promised outcomes have been transferred, and I give you a third one on top, and that is a more practical one. So the assets that we have produced, for instance, this concrete GSN model that we've seen in the presentation, could be a starting point for argumentation teams in the companies to actually go and apply the method, the argumentation method that we have developed in a project. And yeah, this is not everything about argumentation, so there's more to come. We have in stream 1 3 talks dealing with different sub-aspects of argumentation, and tomorrow there's going to be a session in the International Day dealing with argumentation as well, but more with the relationship towards the international context. And with that, I would like to wish you an insightful, inspiring VVM final event, which continues with an overview of the overall assurance methodology given by my colleague Helmut Schittenhelm. Thanks for listening.